Welcome back. Just want to bring out something that last time a video that I didn't mention a lot about this. I just saying what was one from the priorities. We can take note of this, right? I would say something like this on the last video. All right, and I didn't put much of the details about this one. Now about this, it depends case on case, of course. Well, for example, let's using this property to solve some problem. All right, so let's imagine, right? Now let's imagine I have a straight line like this, and this one, let's just say y is equal to x. And I want to measure the area in between -1 and 1. All right. And so the interval is from -1 and 1. So let's do the integrations. All right. So let's do it like -1 and 1 here, right? X. And of course, let's highlight this. We want to find the area of this, right? And dx. Well, what's this equal to? Now it's equal to, well, let's integrate the x first, and then we can find what the value is. So let's integrate this. After that, we put 1 and -1 right here. All right, and so let's find the area under the curve. So x squared, right? Sorry, so not x squared, but it has to be 1 squared minus 1 over 2 -1 square, right? And of course, -1 square is, so this one is 1, -1 square is 1. All right, and the x there is multiplication, not the x symbol. My apologies. And I got 0. All right, so if I didn't bring into this form, and I didn't bring into this form, right? So I didn't use this one, I got the area is 0. Now it kind of makes sense. Why? Well, because this part here is in the positive side of the y, right? So just place on y. This area here is in the positive side. This area, however, however, is in the negative side of the y. And so that's the reason why we got, no, if we add those two together, so we got the area for the first part is 1/2, right? The second half is 1/2. So if we're subtracting them out is 0. It makes sense. But well, it's not like, well, now the problem now is like, how am I gonna find the real area of this, right? I don't want it to be 0, because if I calculate the area is 0, it's not true because we have the area under the curve. And so how are we going to do this? So we apply this property right here. So we do this property to find the area under the curve. And so I shouldn't be erasing that, so rewriting that one. It's okay to rewrite it anyway. Shouldn't care. Now, if I rewrite this one, all right, so it's evaluating from 0 to 1 of x dx, right? So it's equal to 2 times, well, it's 1 over 2x, right? Evaluating from 0 to 1. Now, everything seems to make sense, right? So now I got like 2 times 1 over 2 is equal to 1 unit square. Now, this one, so 1 unit square, the area is equal to 1 of both case. This makes sense, right? Because this one is 1/2 and this one is 1/2, right? 1/2 plus 1/2 is equal to 1, right? And so that's the reason why we can use these properties to actually solve this kind of problem. Now, does this always following this? Like, does this properties always hold true? No. The answer is definitely is not. Now imagine I have something like strange graph. I have some strange graph where I don't even know what the function is, but I just draw it, right? And let's say look like this, all right? And this interval is a. This one is this one -a. This one is a, Right. Now clearly we see the area under the curve. So from negative a to 0, I got this one, but from 0 to a, I got this one, right? So it's not working out at all. So this properties doesn't hold true at any time at all. It only holds true if both sides of the area are equal. Now what I mean by both side areas are equal, let's evaluate this one. So back to the sign question. All right. So the last previous video, I say something about this one, right? So I last time we measured this area here is equal to 2, right? This area is from here to there is 2 pi. Now, last time we measured from 0 to pi of the function. So the function is f of x is equal to sine x, right? Function sine x dx, right? Then I got the area is equal to 2. All right, so this is from the last video. Now, again, if I want to measure the area from 2 pi, 0 to 2 pi, well, that means it depends. So it really like, let's say sine x dx, right? Now, from the previous problem, we kind of know that, all right, so this area is on the positive side of the y, right? This area is the negative side of the y. So these two has to be equal to one another. And so if I didn't use that property, right? If I didn't use that property, and I'm trying to measure the area on the curve, for sure this integration is equal to 0, as exactly as previous one. Now, in order to get this one, we have to use the property. Now, that I mentioned in the earlier in the video, this video. Now, the problem for this is always we recognize that symmetrical area um, from from this one positive and the other one is negative, but they are the same area. This is when this properties can kick in, and so I can write, well, I'm measuring from 0 to pi of sine x dx, right? Now is equal to 2 all right, 2 well, let's draw something like this, to 0 to pi, and we did saying this whole thing here is equal to 2, right? So 2 times 2 is equal to 4. And so the area here, so this one, it makes sense. So this one, area plus with this one, so 2 plus 3 is equal to 4, which makes sense, right? So the area is equal to 2 plus 2 is equal to 4, and it makes sense. All right, so yeah, so this properties we can only use if we have some symmetrical thing what we're trying to measure. If only if it has a symmetrical area in between them. Now, does sounds confusing. It does sound really really confusing, but again, the trick is always that if you encounter this one, all right, if you encounter this property, and you do the integration and you do everything, and it's equal to 0, then you have to come back, make sure this guy will make sure identify the central point of it, and then bring it to 0, and then you can then calculate a some number scalar there. Now, that's the only trick if you don't draw the function out, right? If you, for example, the same thing on the sine function as well. So if you do this integration very quickly and you see that it's equal to 0, then you find the symmetrical point is usually is between them, between these two intervals. And so usually what we do is take 2 pi minus 0, so totally 2 pi plus 0, divide by 2 to find the point, the center point, and then I got the pi, sorry, then I, sorry, this one. So this one here is like 2 pi plus 0 over 2. So this one's 0, 2 times. So we do something like that. If you want to work out another example, let's do it. All right. So I can't think of anything else that has a symmetrical point that, make the area go to 0. Let's do this. Let's try this. Let's try this. This one here, this one here. This one f of x is equal to absolute value of x. Now, so we're evaluating from, let's crank it up to 2 and negative 2. Now, of course, you can use Pythagoras theorem to solving this. All right, you can use, Pythagoras theorem solve this because you have the height and you know the base, right? You have the base and you have the height. You can find the area very simply. But let's do this with the other way of using integral since we're learning it. All right, so let's doing this. So again, let's assume so the function is from negative 2 to 2 of the absolute value of x dx. All right, how can I do this? Now, the trick for absolute value is that, well, if x is negative sign, so if x is in the negative, so this, if x is on the negative sign, the value of x is negative x. That's obvious, right? If it's on the positive side, then the value is positive x, right? How are we going to do this? Now we see, oh, sorry. My God, another slap on my face things. Now, so let's do this. Okay, so if I want to evaluate this integral, I'm going to introduce you another property. But now, so I know it divide it as symmetry as 0, so I'm going to divide it to 0, right? So exactly the last time I'm saying, so I can change 2 times to 0 of so because this one is from 0 to the interval from 0 to 2 is a positive x, so I only take care of x dx, right? So this one is multiplied, by the way. There's so many problems right here, right? So what I do again is, well, we're gonna integrate this from x from 0 to 2, so I got like 1 over 2 x squared, measuring from 0 to 2, and then I got 1 over 2 times 2 squared minus 1 over 2 times 0 squared. That gave me 2 times 1 over 4, this one go out, so that will equal to 4 units square. All right, so yeah, so that's how you do it. All right, so now remember that this is a property works for everything, okay? This is a property works for everything. But by the way, before I jump to the next properties, again, so be sure to make sure you understand this. All right, make sure that you fairly got this idea of this.